Hello, welcome. So in this series, I am building a FPGA stack machine CPU from scratch. And in the previous few episodes, we've been building out this processor here. We've got some program memory, and right now we've got an assembled program in it. We've got a microcode ROM that is translating the opcodes into some microcode lines, or some control lines, I guess would be the better term for that. We've got the control lines being displayed up here. We've got an immediate from the program going into the immediate input here. And we've got a stack, which has the top of stack, the next on stack, and the third on stack being displayed, arguably in the wrong order, but that's okay because this is very temporary. And we've got an ALU in air quotes because it's just an adder right now and it's not doing anything else. I think what would be nice to have is a way to test this processor. Oh, and by the way, my apologies for the last episode where I had VS Code in dark mode, and then I was switching between digital that's in light mode and VS Code that's in dark mode. So if that was hard on your eyes, I apologize. But yeah, I guess the other thing to note is that we've got microcode going now. Let me just close that. We've got microcode where we're setting up the control lines in here, and each address is a new instruction currently. We might eventually make it so that multiple instructions can be executed per macro instruction, but we don't have that set up yet. So we've got these instructions implemented, and then we've got a bit of a CPU def for a program. And so we've got the instruction, these are the instruction addresses from the microcode. So these are the addresses here. Probably help if they were in the same format. So anyway, that's okay. Could probably just as well change them here, actually. But I'll do that later. And then we've got some rules for each of the operations, and we would have a different one of these rule defs here for each instruction format that we would have. And then these are the instructions. And then we've got a little program here. In the long term, it won't be in this file, but for now, this is fine. So that's what we've got set up so far. What I like to do is get an automated test going as quickly as possible. And really, in order to do that, I think we need some sort of conditional branches. And really, you need conditional branches to be Turing complete anyway. So that would be good to be Turing complete quite early. So let's work on that. I think probably the easiest is just to get a regular jump going. So we would have to run this line here into an adder that goes into the program counter, I guess. So let me work on that. Okay, this seems to be working. Now we just need to test it. First, let's just make sure that we haven't broken anything. Seems to be working just fine. One thing that would be nice is to be able to see the program counter. What's a good place for it? Up here, I guess. Right here. That looks good. Okay, and now we need to update the microcode. So this would be the jump instruction. We need a jump control line. That's the 5th one. I think that's everything there. Then we need a jump instruction here. So this $ means the current program counter. You can also use PC, I think, and that's the same thing. I always forget what the formula for this is. So let's just test it out. We'll just put a jump at the bottom here to program, and we'll see if it calculates the address correctly. It should basically calculate 0 and jump up to 0, basically. So I just said basically a lot. Yeah, these episodes are not super well edited on purpose because I don't like editing, and I don't want that to be a deterrence from making videos. And you probably would agree with that. You'd rather have videos that are not very well edited than no videos at all. So I apologize, but that is how it is. And, if I wanted to become an editor, I'd be editing. But I don't. I want to just play around with making CPUs, and I want to be able to share it. So it is what it is. Okay, so we've got this. Now we need to actually run the custom ASM to build everything. So I'm going to be in the terminal, and thankfully that's already there. And then that would be the program one. Okay, now I got to go back to digital here. Let's see. So we got to load program into here. There's a way to auto load. I might set that up at some point. Program. That doesn't look correct. No. It's negative. So yeah. Okay. It's probably fine. And then the microcode. Okay. Now let's see. Will it jump? 3, 4. I don't know when the jump comes. I guess when this light turns on. Okay. That is that. What's this calculating? 0. That looks right. Wow, I guessed correctly first time. Wow, okay. Usually I have to adjust that a few times before I get it right. Okay, it's jumping back to 0, so that's awesome. So the other thing that we need to be Turing complete is we need a conditional jump. So it needs to be able to make a decision, in other words. If it can't make a decision, then it can't do things differently depending on what happens. And so that means it's not Turing complete. So we need a way to make a decision. And the simplest thing for a stack-based CPU is whether or not the top of stack has a 0, because then you can always subtract, basically, and either get a 0 or not get a 0, and that would be, you know what I'm talking about. So we need a way to detect if the top of stack is 0. So we have a comparator here, And we've got the top of stack. And we got a 0. Okay, we've got a line that tells us whether or not it's 0. And we've got a jump line. Well, if we have another microcode line, or even 2, do we want 2? Sure. So we've got 2 lines. And we're running out of space again. Let's see. So, we got space here if I move this. Actually, if we just have 2 lines, yeah. So if we have 5 and then 2, 6 and 2, or no, that's what we want, 5 and 2. And then this would be, yeah, I don't like it. I'm just going to go with 8. We can encode these more later. It's easier if we don't encode them right now. And then we can just take this off down here. Anyway, I'll be back when I've got this done. Okay, so we've got a comparator here. It's checking if it's 0. It'd probably be more appropriate to make this like a NOR gate or something like that, but digital doesn't have, I don't know what the term is for it, where it'll NOR all of the bits of like a 16-bit number in one gate, or one symbol, I guess. Digital doesn't have that, so instead we're just using this. And then it goes to a pair of AND gates. One is negating the condition. That's what the circle means. So then it's either that signal is high and the and it's 0, or it's high and it's not 0. And then that's just going into a triple input OR gate to figure out whether or not the jump should happen. So I think that's all we need here. Now, of course, we've got to update the microcode and the program. So let's do that. Oh, while we're here, another thing that would be nice is a way to halt the processor. But we're out of control lines, so and we're out of LEDs. I suppose we could just crunch these down into 2. Let me just do that. Yeah, because I want to be able to halt as well. So, and we've only got 8 bits in the microcode so far. So yeah, okay, let me just do that. Okay, so we've got a halt line now, one of the bits here. The halt line goes up and just stops the program counter from incrementing anymore. And if it can't increment anymore, then the processor is effectively inert. So that's the simple way to implement that. So yeah, let's get the microcode going. I also switched to just using a mux here to determine the jump condition. So the jump condition is either always jump, jump if 0, or jump if not 0. And I don't have a display for the jump condition here, but then this will highlight. You can see the little circle here to note the jump condition. So I think that's fine. That will work for now. So I'm just going to switch to implementing the microcode. Oh, it just occurred to me I need a jump never. There we go. So we've got a jump never, that's 0, and then always jump, jump if 0, jump if not 0. So that should work. Okay, so we've got jump if 0 here, and I've just loaded -7 added, so then that'll subtract 7 basically. And if it's 0, then it'll jump to OK, and it'll halt here. If it's not 0, then it'll jump. It won't jump, and it'll halt here. So then we can tell the difference between these two. So this will be at 0, 1, 2, 3, 4, 5, 6, 7, 8. So if it halts at 8, then we know it passed. And if it halts at 9, then we know it failed. Or wait, the other way around. At 8, it failed. At 9, it passed. So then we just have to assemble these and test. Okay, let's see. Things look like they're working correctly, I think. So we've got 1 and 2, they become 3, then 3 and 4 becomes 7, and then minus, oh, we should maybe change these to be signed, but -7, and 7 becomes 0, and then this line turns high, and we're actually checking that line now, and we're jumping. And now we've jumped right into a halt, and the halt line is high, and the program counter is inhibited, so now it won't do anything, and it's at 9. And we knew that 9 was when it succeeded. Now, generally, probably what I'll do is just have the test program loop. And so we can set the clock to like some high frequency. And if it never halts and it keeps working, then we know everything succeeded. If it ever halts, then we can look at the program counter and figure out where it halted and what is failing. So then we can just build one long, big test program that tests all of the instructions, and we'll be able to loop over and over and over again. And if it ever halts, we'll know exactly what failed because it'll halt close to where the problem is. So I think that makes a lot of sense. So I'm just going to head over to the assembler here and actually make a little bit of a macro for this pattern right here. So this pattern always jumps 2, I think. I think that's jumping 2. Yeah, I think. So then we can have a couple of macros. Halt not 0 would be no, it would be jump 0. 2, I think. And then we would have a halt in here, but we can just use this. And the reason I'm doing this is so that it doesn't do the label $ thing. I think that's what we want. So halt if not 0. If it's 0, it'll jump over it. And if it's not 0, then it'll hit the halt. Yeah, I think that's what we want. And then we've got halt if 0. And in this case, if it's not 0, we want to jump over the halt. And then we would want here a halt NZ, because it should be 0 because we subtracted 7 and we know that it gets 7. So then that would be the first test case, basically. And we can just call this beginning. And we can say this is the first test case, test. So it's testing the addition and the load immediate, I guess, as well. But and then we could have another test case that tests, what do we got? Drop. We could test drop, see if drop works. Well, we want to load 0, load 1, drop, and then 0 should be on the top. So then if we want to halt if not 0, essentially. So there's our second test case, and it's testing the drop instruction, which we haven't actually tried yet. And then we jump to the beginning if everything passes. So then it will just loop. So we'll just compile this. Oh, I'm missing an underscore here. Whoops. And it jumped back to the beginning. So now we can just cycle through this and we know that all of the instructions are working. And it looks like the drop instruction did indeed work. So we've got the 7, and then we've got -7, and then we're trying loading at 0 in there. And there's the 1, and then it gets dropped. Stack pointer being 7 is a little concerning. Yeah, we're putting too many things on the stack. So we've got a stack leak. So eventually the stack pointer is going to roll over, which is not good. And we don't have a way to actually detect that and halt in that case, which actually would be nice, but we'll add that later. In the meantime, I'm just going to correct the program. We got to drop both of these. So I'm just going to drop it here. And then I think we got to make sure that we drop after here as well. Yeah, because we add pushes it on there. So we've got to drop it off. And then we've got the 0 and the 1, and we got to drop both of those. So that should return the stack to 0 after each loop. I guess that's a good thing about looping, because you'll notice that the stack is growing without having to do anything to detect that condition per se. You can just see what the program's doing. Okay, I didn't assemble it. 1 second. I gotta probably just set this to reload at model start. I have a lot of hobby stuff. Okay, and then might as well set that up for the... I wish it wouldn't reset to the home folder every time. That's super annoying. Okay, so we should be able to go through here and see that the stack hovers right around 0, which it does. Excellent. So we could probably even just set this to go 5 times a second. Sure. There we go. So we have ourselves a way to test the processor, and we're in the 3rd episode. So that's awesome. What's a good name for this episode? There we go. That's a good name. So yeah, thank you very much for watching. The usual blah, blah, blah. There's a link to this program in the description, or you can search for his name and digital, and that should come up on Google. There are links in the description if you're feeling generous. I don't make very much from ads and YouTube Premium because, well, this channel will never get very big probably. And if it does, well, then don't worry about it. But in the meantime, if you are feeling generous, everything helps out. Just a little bit goes a long ways to, buying equipment and things like that. If I need any equipment, I don't know. Guess we'll see. And what else? Yeah. The other thing. There's a link in the description to the GitHub repo for this project. There is a commit for every episode. You can look through the commits on GitHub, and you can find the commit for this specific episode and get this program and play around with it. Now that I've set these things, you may need to change this file because the file is an absolute path, which is kind of silly. So you'll have to go in here and change it to the path to the program hex, and also in the microcode, you'll have to change it there as well. That's kind of annoying. I don't know if there's a way to fix that. So yeah, you'll just need to fix those two, and it should just work for you after that. So yeah, thank you very much for watching. I hope you have a great day. Bye.